Ever wonder how software tools unravel the tangled web of function interactions in a program? It's like mapping a city's traffic patterns, but for code, where every function is a vehicle and every call is a route. Today, we're diving into GRAPHIA, a revolutionary AI tool that uses graph neural networks to map JavaScript functions with unprecedented precision. Let's break down how it works. First, what's it called? Graph. Imagine a social network for code. It's a map showing which functions interact, like a city's road network. These graphs are vital for debugging, optimization, and security, but JavaScript's flexibility complicates things. Functions can act as variables, be dynamically assigned, or change behavior at runtime. It's like trying to map a city where streets shift every minute. Traditional tools struggle here, often missing connections or creating false ones. That's where GRAPHIA shines. It leverages graph neural networks, GNNs, a type of AI designed to analyze relationships in complex systems. Think social media or transportation networks. GRAPHIA treats code as a graph. Functions are nodes, calls are edges. But here's the innovation. It doesn't just map obvious calls. It uses syntactic clues like function structure and semantic clues like data flow to predict hidden connections. For example, if a function is frequently used in a specific context, the model learns to infer where it might be called next. Here's the technical breakdown. GRAPHIA starts by creating a detailed static analysis of the code, capturing not just function calls, but also variable assignments and data dependencies. Then it trains a GNN on this structure, teaching the model to recognize patterns. By combining static analysis, examining code without execution with dynamic data, behavior observed during testing, GRAPHIA adapts to real-world complexity. This hybrid approach lets it handle multi-file programs, a challenge previous methods couldn't solve. In tests across 50 popular JavaScript libraries, GRAPHIA achieved 42% accuracy in resolving ambiguous calls and got the top 5 answers right in 72% of cases. That's a massive improvement over older tools, which often missed critical connections. What's more, it's the first method to apply GNNs holistically to large-scale JavaScript projects, not just isolated snippets. Why does this matter? Accurate call graphs enable smarter debugging, better security audits, and more efficient optimization. By bridging static and dynamic analysis, GRAPHIA reduces false positives and uncovers hidden vulnerabilities. For developers, this means fewer surprises and more confidence in their code. So next time you debug or use a linter, remember, AI is quietly transforming how we understand code. Thanks for watching. If you want more deep dives into code's hidden mechanics, hit subscribe. And drop a comment. What other tech mysteries should we unravel? Ever wonder how software gets so smart? It's not magic, it's breakthroughs like graph neural networks, GNNs, rewriting the rules of code analysis. Let's unpack how this tech is turning complex programming puzzles into manageable problems. Think of code as a web of connections. Traditional tools. They're like trying to navigate a city with a map that only shows streets, not the traffic between them. GNNs, though, they map relationships, like seeing how every intersection, road, and detour connects. This lets them spot hidden patterns in code, like sneaky bugs in JavaScript that static analysis misses. It's code's secret decoder ring. Why does this matter? Imagine software that doesn't just check for errors, but anticipates them. Better code analysis means fewer crashes, faster fixes, and tools that actually understand what you're building. It's the difference between a calculator and a math tutor, except for computers. And this isn't just theory. Researchers are sharing their code and data, turning this into a collaborative leap forward. Take CodeBERT and GraphCodeBERT. They're like AI translators for code, trained on millions of programs to recognize syntax, logic, and even coding styles. Or Oreo, which hunts down duplicate code fragments that could hide security risks. And tools like Hoppity don't just find bugs. They teach AI to fix them by learning how code structures break and heal. The goal? A future where computers don't just read code, but comprehend it. Picture a world where debugging feels like having a genius assistant, or where AI helps design software as intuitively as we write essays. This is the next frontier, where code becomes smarter, safer, and more human-like. So next time you update your app or use a new coding tool, remember, behind the scenes, researchers are building the brains of the digital age. Stay curious, keep exploring, and let's code the future together.